Hello everybody, my name is Craig Bennett and I'm the founder and owner of TechViews and Help.
And I'm AI.
And today we are going to talk about how Newton's three laws affects and it plays a very critical part in orbital mechanics. Now in the background I'm using Kerbal Space Program to show how these affect, because Kerbal Space Program is the closest software that I have to real world space stuff as far as orbital mechanics, getting a rocket take off and whatnot. It's a very great program to learn this stuff, and I'll leave a link below on where you can get it, and I highly suggest you check this stuff out. Now as far as things goes, if I go too fast, too slow, then feel free to play with the skip button and whatnot to go forward or go back a little. And the numbers do work as far as pushing the video forward and whatnot. So as far as things goes, again, we're going to talk about the three laws and how they affect, and this is going to be a pretty short program. AI, what are the three laws?
The first law is, an object at rest will remain at rest unless acted on by an unbalanced force. An object in motion continues in motion with the same speed and in the same direction unless acted upon by an unbalanced force. This law is called inertia. The second law is, acceleration is produced when a force acts on a mass. The greater the mass of the object being accelerated, the greater the amount of force needed to accelerate the object. Lastly, for every action there is an equal and opposite reaction.
So, basically the first and second law means a rocket, you, or anything else won't move or will keep moving depending on if you're at a stable space or if you're already at movement until something acts against you or whatever it is, being a rocket or whatever it is. This is important for multiple reasons, because you will not get the rocket itself to take off until you get enough action behind it, and that's a very important thing.
By the way, you are in an orbit when you jump. The apopsis and periapsis aren't at the right numbers to get you in an elliptical orbit. However, some scientists believe it is possible to jump in an elliptical orbit in a very low gravity body.
This is 100% true, and the reason why it's 100% true is you have the gravity and whatnot going against you. Let's say you take that out of play, as the AI said. If you put yourself in a low gravity body, let's say the atmosphere is very thin where you don't have to break through it and don't have to deal with that drag, then you can easily run and jump and go into a elliptical orbit, and you kind of will be stuck there until you're either able to grab something or do something to change your mass and speed. That's a very critical thing, especially around space and whatnot, because what happens if you launch something or put something in space or something gets disconnected? It goes around and there's nothing to stop it except for the microatmospheric drag, which will mean that the thing will come back down, but within a good 500 years. So yeah, that's the problem. I mean, that's obviously depending on how far out it is. So yeah, that's very important to note. So I wouldn't be jumping around on certain asteroids or certain things, but in the overall, that's very important to note. Now on to Newton's third law. You most likely heard this, and this is one of the most famous laws, physics laws actually out there to date. It's, for every action there is a equal and opposite reaction. This means the rocket's action is pushed down on the ground with the force of its powerful engines, and the reaction is the ground will push the rocket upwards with an equal force.
To put that in layman's terms, in swimming, a person interacts with the water, pushing the water backward, while the water simultaneously pushes the person forward. Both the person and the water push against each other. The reaction forces account for the motion. By the way, it does not matter which is called the action and which is called reaction. Both forces are part of a single interaction, and neither force exists without the other.
In other words, the mixture between Newton's second and third law will force the rocket and not the planet, or whatever it's launching off of, to move. This is why it isn't smart to launch a rocket off of a station, or a chunk of a small rock, or whatever else that has a small mass. And particularly what I mean with this is whatever force they use here to take a rocket off, you don't want to use a enormous amount of force like that on a station or whatnot. In other words, you're going to throw the station out of whack because the forces are massively different, and you're going to throw the rocket possibly off depending on how things go. So it's very important to note that when you're detaching from a station or going from a meteor and detaching from the meteor by launching off a meteor or whatnot with a low gravity mass, the simple fact is use less force. In other words, you're seeing that thing flying through and you just build up the speed for that one thing, which goes into the second law. So anyways, if you got any questions or whatnot, feel free to leave a comment below, or you can email me on techreviewsnote.com or email me on YouTube, and I'll try to get back to you as soon as possible. If you got any tips or whatnot, you can leave them below. This is, as you may know, the first video in the series of orbital mechanics, and depending on how things goes, depending on how deep I'll get. But I'm trying to cover the basics, therefore people can use this in school and whatnot. Have a great day.